between 0 and 2 pi, so we're not gonna have,
Let me write like this. And I think the author of your textbook has that to be open. So here they want you to list the particular solutions. Just list those in one revolution, no need for a K pi or some sort of thing like that. Guys, on this one, I think I heard some students talk about something like this during the break. This translates into, here we go. There's your focus. And keep in mind, I've got to give you something that you will recognize. Guys, I guess I think I've seen that tonight. What on that unit circle has for a cosine, x coordinate, to be 1/2? Pi over 3. So that tells me quickly, this must be representing pi over 3. Now I am going to write like this. I know the period number to make things repeat. For cosine is 2 pi. To make another revolution, so I am going to write like this. Even though I may not use it. Now, call that number 1 there. Number 2, I think though, there might be another possibility on that unit circle for an angle whose cosine is 1/2 besides pi over 3. What is it for cosine? 5 pi over 3. That says that 2 theta could be this. And I'm going to use that period number to make things repeat. Now guys, what I've really done here is I've written out the general solutions. Now keep in mind, we picked these up from the unit circle. I hope I picked the correct ones. Now, they said solve for theta. I'm not quite finished. So I go back to number 1. I got to do this. And of course, those will cancel. So theta is going to be equal to, when I clean this up, that's what, pi over 6 plus these 2's will cancel. Pi k. Do you guys agree? Okay. Next one, same thing. Divide by 2. And if I divide by 2 here, guys, and we end up with theta's equal to, looks like it's going to be 5 pi over 6. It's just math here. Plus pi k. Again, where k must be an integer. And watch what I'm going to do. They're saying just list as many as you can, even though I have the general solution. List as many as you can, just caught between these 2, and then we'll be finished. Guys, what I would do, suppose I could go back to the first one, and let's start with k to be a 0. 0 is an integer. If I replace k by 0 in my first solution here, I'm going to end up with this dropping out, and end up with what, pi over 6. Is pi over 6 caught between these 2 right here? So I will list as one solution pi over 6. If, I don't think it's going to happen, but if I should replace k by 1, it says maybe replace k by any integer you wish. Nathan, if I replace k by 1, I'm going to get pi over 6 plus 2 pi. And I think that's going to take me outside what they want. It's going to take me outside this interval. Even though it is a solution, they do not want it. They want only the ones called here. So I can't do anything else there. Down here, replace k by 0. I see 5 pi over 6, which I think is what, 150? And that would fit in this interval. And I think I'm going to close it up. I think those are the only 2. You guys agree?
Okay, why could we not replace k by 1?
Okay, 1 where now? Up here?
The top one, yeah.
Okay, I end up, well, let's see if we can. If I replace k by 1, you get pi, 7 pi over 6. Is that 7 pi over 6?
That's inside the interval.
Now, is 7 pi over 6 within this interval?
Yes.
Okay, 7 pi over 6. If it is, we'll pick it up. Is it what you guys were saying?
Yeah.
Before I read this here? So I got pi over 6. Let's make sure now. I've replaced k by 0. I got pi over 6. Replaced k by 1. You're saying 7 pi over 6. Cannot replace k by 2.
No.
0 down here, I get 5 pi over 6. Replace k by 1 down here, guys, but I end up with 11 pi over 6.
Yeah.
Is that another possibility?
Yeah.
And now, well, those 4 now all fall within this interval. It all depends on this. They're gonna tell you where it should fall. And that will determine how many of those you are to accept. Before I leave this one and go to the next one, if this had been from 0 to pi, and they'll give the restriction to you. If they said just find the answers caught between 0 and pi, I can still use this one. I can still use this one. I don't think I can use this one,
No, or.
nor this one. So that next time, or the other time would be only these two, if that should happen. Because it's between 0 and pi. Woo! Jacob, come to the next one.
The next one is 2 sine squared of theta
Hang on now, 2 sine squared.
minus 3 sine squared theta.
Uh-huh.
Or 3 sine theta, excuse
Okay.
me,
Give me more.
plus 1 equals 0.
Okay.
And the restriction is between 0 and 2 pi.
Okay, all right, like this. Here we go. Guys, this looks like it might be one of those calling for what, Austin?
Oh, I'm just a little bit confused on the question before, like, because if you do 5 pi over 6 there, it would be negative 1/2 instead.
Hang on now. Let's see if we messed it up here.
No, it would be positive, because it's cosine.
Are you thinking about cosine?
Yeah.
Which one of these four?
5 pi over 6.
So if I put 5 pi over 6 right here and multiply it by 2, that becomes what, 5 pi over 3?
In quadrant 2.
And 5 pi over 3 is where? Where's 5 pi over 3? Is that in quadrant 4?
Yeah.
Oh, sorry, never mind.
Okay, okay. Now, what do you think the next one's looking for? The next one. Let you be something.
Yeah.
Also, what you just said there, sometimes we all do that. I've done it myself, getting the wrong quadrant there. This becomes 2u squared. And I'll go ahead and put what that u was. And we'll let u be representing sine theta. You guys agree? I hope it factors, Sophia. If it doesn't, we'll use quadratic formula. Here goes 2u, right, -1 and -1. You step back. Yeah, looks good. We've done these many times. I'll go ahead and do this quickly. This is u here. This is u. U was representing what? Sine theta. So this really says sine theta equals 1/2, and sine theta is equal to 1. Okay, guys, it always takes me to the unit circle. We cannot use calculators on the test. What or where on the unit circle have you seen the y-coordinate sine equal to a 1/2?
Pi over 6
I hear 5 over 6.
or 5 pi over.
5 over 6?
Yeah.
Now let's make sure that's, with those two fit
Yes.
here, I'm good. Now, have I seen somewhere on that unit circle the y-coordinate sine equal to a 1?
Pi over 2.
Pi over 2.
Or 3.
No, don't go there.
Oh, alright.
3 pi over 2 is a -1. You guys agree?
Mm-hmm.
And all those, I think, would fit between these two, the restriction. So my solution set would contain 5 over 6, 5 over 6, I don't care about what order you place these, 5 over 2. You're done. I think these are a little bit easier than inverses. I think they're a little bit easier than inverses. What's the next one?
The next one is tan
Okay.
theta divided by 2
Oh, tan theta over 2.
equals radical 3.
And did I give you a restriction?
That it has to be between 0 and 3 pi over
3 pi.
2.
3 pi.
3 pi over 2.
3 pi over 2. Was it open or closed?
Both of them were parentheses.
Okay. Okay, guys. Now let's make some sense of this, much easier than inverses. Guys, I'm focused on this. Can someone tell me, and I'll check it, where on that unit circle have you seen y over x tangent come out to be a radical 3.
Over 3.
I heard pi over 3. Hang on. And I'm checking, make sure pi over 3, guys, I'm checking the coordinates in my mind here. That's 60 degrees. I think it does give you a radical 3 over 3, does it?
Mhm.
Okay. Is there another one that gives you a positive radical 3?
4 pi
4
over
pi over 3.
I heard 4 pi over 3. And that's on the unit circle also. You gotta know these. Now what am I gonna do? I'm gonna say now, step 1, theta over 2 could be representing pi over 3 plus, I'm going to write out the general solution, even though they just want a couple of particular solutions. The period number. Can anyone remember what the period number, be careful, on tangent, to make things repeat when I did the tan graph when we found the period? It was 2 pi over here for
Pi.
cosine. It's pi, not 2 pi. Where k is an element of the integers. That makes things repeat, the pi for tangent. If I go ahead and solve this, multiply everything by 2, not too exciting. If I multiply everything by 2, guys, it's 2 pi over 3 plus what? 2 pi k? Where k is an element of the integers. And let me block this off and see if you guys will agree there. Is that true?
Mhm.
So that's one of them. Number 2, you said the other possibility would be theta over 2 could be representing, in the red there, 4 pi over 3. Period number, pi, k, where k is an element of the integers. Multiply by 2 on this one, theta is equal to, looks like, guys, is that 8 pi
Yeah.
over 3 plus 2 pi k, where k is an element of the integers. Do we agree with those?
Mhm.
Now, they want only the ones that you capture between 0 and 3 pi over 2, 0 and 270. You guys, if I go up to this one, replace k by 0, of course this term drops out, leaving me 2 pi over 3. Would that fall between these two? Now, if you like degrees, you got 0 and 270. If you have 2 pi over 3, I think that's 120. That's 120 fall between 0 and 270.
Yes.
So I can use that one. If I replace k by 1, I think we're gonna go over. Is that true? You could try it. Now let's jump down here. If I replace k by 0 on this one, Nathan, I'm gonna end up with 8 pi over 3. If you prefer degrees, that's 60 times 8. Is that 480?
Yep.
I did it quickly, 480? And that would definitely not fall here. Is that true?
Yep.
So I'm finished. There's only one answer. Based on where they asked me to find it, between 0 and 3 pi over 2. This is mathematics. This is it. Guys, any questions on this? It's going to take a little time to absorb all this. Okay, Jacob, go for the next one.
Next one is secant of 3 theta over 2
Hang on now, 3 theta over 2.
equals -2.
Okay. Oh my goodness. I still think these are better than inverses that we were looking for the course. Guys, on this one, some students may be able to tell me at this point what this might be representing on the unit circle. There's an angle out there that when you take it secant, you get -2. If you don't like secant, you could say, Professor, does it not mean this also, which might be easier for me? Are these two statements really saying the same thing?
Yeah.
Yeah.
Because these two are reciprocals. So it might be easier to think of it like this. It's up to you. Now, can anyone tell me then, where on that unit circle have you seen cosine, the x-coordinate, equal to a -1/2?
Pi over 3?
Not pi over 3.
Or, sorry.
It's a negative.
No. Oh, is it gonna be a negative?
-1/2. Where have you seen -1/2?
pi over three.
There's 2 pi over 3. That's one consideration. Hang on. It'll be equal to what, 2? Hang on, 2 pi over 3. By the way, this is the cosine with the period's back to 2 pi now. Make things repeat. And there's 1. Not quite finished. I'll come back to it. Now, is there another that we're overlooking besides 2 pi over 3 where the cosine, the x coordinate, is a negative 1/2?
4 pi.
4 pi over 3. So this could be representing this plus the period, this. Okay guys, let's go back and solve each one of these. I gotta be very careful. Oh boy, this is gonna be awkward. I could multiply everything by 2 first. I think I'll try that. You get this. Oh, this one's gonna be a strange answer. And then divide everything by 3, guys, help me out here. Divide by 3, does this become 4 pi over 9? Yes or no?
Mm-hmm.
And on the end, divide by 3, does this become 4 pi over 3? K. And I should say K is gonna be an integer. This in the red is a general solution to work with. Now you're gonna see some of these on the exam next Wednesday. I don't want you to mess up on the last exam. Okay, I'll come back to that. This one, if I solve it, number 2, multiply everything by 2. I gotta be very careful. I think it's 8. Oh my goodness, it's 8 pi over 3 plus 4 pi k. K is an element of the integers. Divide by 3. Do not let me make a mistake. Is that 8 pi over 9?
Yeah.
Plus 4 pi, where am I? Multiplied by 2. 4 pi over 3, was it? Yes, K, where K is an element of the integers. We're trying to keep it organized. Oh my goodness. Is that true?
Yes.
Are those my 2 general solutions? Now, I may have to end with this one pretty soon. You get a lot of credit there. Now, they're going to ask you now, please look at those 2 and list as many as you can. What was the restriction on this one?
0.
0 and 2 pi.
Okay, right like this. Okay, I think we might see something there. Here we go. I'm gonna do this, guys. Let's start out with K to be a 0. If I let K be a 0, this drops out in that general solution, leaving me what? 4 pi over 9 for theta. Jacob, I'm ending up with some strange numbers. And it might be awkward to try to see whether or not this fits here.
Mm-hmm.
If it doesn't, I can't use it. So I do see a 9 coming out. Oh my goodness, 4 pi over 9, guys, that would be like 0. If you change this to a 9, that's what? 18 pi over 9? So would that
we're
fit?
between it. We're good.
Okay. Now, maybe there may be more. Let's let K be 1. Same solution here. That would be, oh my goodness, 4 pi over 9. I better be careful myself here. 4 pi over 9. Replacing K by 1 makes that what? Plus 4 pi over 3?
Which is 12 pi over 9.
I'm here. So I see 3, 12 plus 4, 16.
That would work.
16 pi over 9. What's some strange answers here? Would that fall here?
Yeah. And another one you can't plug it.
Thank you. I'm sure you why you cannot. Sometimes you go way down there towards the ends. We'll try one more. Let K be 2. Nathan, if I let K be 2, this thing becomes 4 pi over 9 plus, was it 8 pi? I think, over 3. Common denominator of 9. Is that 28?
Yeah.
28 pi over 9, I think. My arithmetic is correct here. Now, will that fit here? No. No. By the way, it will, if you took the time to put it back in here, where was the equation? Back up here. If it does that, or if you put it in there, it would check. Except it doesn't follow that interval. So the only two I have right now that are okay, that fall here, are those two.
And if you put both of those back in, they would both equal.
Oh, I guarantee you, if you put
Okay.
this back here and you solve it, you'll get a -2. You put this strange number back here and do your business, you'll get -2. You'll put this one back here, you'll get -2. But I can't use this one because it's not here. It's not caught within that interval they want. Woo! Now, Laura, before we slow down a little bit, I'm not finished. I've got to do the same thing where? On number 2. Let's see what happens. Theta is equal to, if I let k be a 0, which is the easiest one, guys, I end up with 8 pi over 9. Which I might add to my, if I've been listing these, I got them circled. I might be able to accept that. Guys, with 8 pi over 9 fall here.
Yes.
That means I'll circle this. That's another answer. Now let's try the next one. KB1. That's where we gotta be careful. That's,
Same as 12 pi over 9.
oh, was it? Okay, 8 pi over 9. Let me make sure. Plus, put a 1 there. It's 4 pi over 3.
12 pi over 9, which would equal 1 over.
Which is, I got a 9 here and a 3 here. 12 plus 8, 20.
Yeah.
20 pi over 9.
Yeah.
Will 20 pi over 9 crazy fit here?
No.
In fact, will not, if it's not, that's the last one then. So I have 3 solutions on this 4 pi over 9. Crazy business here. Was that 16, I think?
Yeah.
Pi over 9. And we finally picked up 8 pi over 9. And those are my particular solutions. I see some faces like either you're tired, or you're thinking about the quiz coming up, or maybe both. Or it might be the new material. Ooh. Oh, I can imagine what this exam next week's gonna look like. Okay, I think this is the last section of the exam though, for next week. I think it's all listed on your handout. Jacob, I don't think we're quite finished yet, are we?
No.
No, okay. I'm gonna do maybe one more. I know we're tired, because I've got a little quiz to do. And then that professor who likes to come in, he's got his little group coming in and taking a test tonight. I like to get out of here before he gets in, so he has plenty of time. Jacob, tell me what the next one is. If it looks too crazy, maybe not, we'll save it. What is it?
Too bad. 1 plus sine theta equals 2 cosine squared theta.
And I gave you a restriction here.
Has to be between 0 and 2 pi.
I think this one's gonna be easier. Why?
We convert 1
I think convert what?
1 plus sine theta. Oh, no. Yeah.
Did I change cosine squared into something? Because I know sine squared plus cosine squared is equal to what?
1.
1, I
So-
can change this to 1 subtract sine squared.
Yeah.
Got that. Get that 2 out front. Still got this. I think this one will get much easier, thank goodness. So we got 1 plus sine theta. Guys, looks like it's 2 subtract this. And since this might be my last one, don't let me make a mistake. It's gonna be a quadratic.
Sure is.
Let's put everything on one side, and one side will be a 0, make it look nice. Move everything to the left, and have this, and hope for the best. And see if you guys will agree. Is that what this looks like with the previous step? Everything moved to the left.
Yeah.
Okay. Now, let U be something here maybe? Sine theta. Everyone ends up with 2u squared plus u minus 1 equals 0. This was looking too much like one we did earlier before the break, I think. Let's factor this. And let's see if it does factor 2u. Looks like, we step back and look at it. Guys, are those the factors?
Yep.
So we're gonna end up with u is equal to 1/2, u is equal to a -1. Nathan, to finish this up, we're now saying sine theta is equal to 1/2. Sine theta, this one's will be much easier, is equal to a -1. This one's sort of straightforward. Takes me back to the unit circle, a good place to end class. Where is sine, the y coordinate, 1/2?
5/6.
5/6 is one possibility. I think there's another.
5/6.
5/6. By the way, both of those, that's 30 and 150, will definitely fall here. So I can't accept those. Here, guys, sine theta is equal to a -1. I think the only possibility is 3/2.
Yeah.
And therefore, together, we have a solution of this. Close that up. Jacob, I'm not going to do any more.
I understand.
How many are remaining?
Oh, Professor, we have a whole nother side.
We have something else besides that?
Yes.
Oh, no, one side's a review for the test.
Oh, okay. Then after that, we just have some identities and we're done. Just some identities that are on here as reference.
Okay, okay. Where it says to establish.
Yes.
Yeah, we can hold up on, until Monday to do those. And this chapter 6 is gonna be out of the way pretty soon. Guys, I know we work hard tonight. We work hard every time in here. We got done though. Now I'm hoping that you do look at your notes and try to make some sense of all this, because sometimes it can get crazy on you. And I try to keep it as organized as possible to make it fall into place for you, okay? Now, if we start this quiz early, which we are, and I'm doing that to benefit him.